So during this tutorial we're going to take our mouse design from the previous tutorial and do a little bit more work on it. So we're gonna create a slightly more realistic design. By the time we finish this tutorial, it'll by no means be a totally finished product, but we'll certainly have something a little bit more realistic than the model that we ended up with at the end of the last tutorial. So this is the PDF that we'll be working from, that you can see on my screen. And you can see the finished output that we're hoping to create at the end of this session. So I'll just zoom in a little bit on that screenshot in the PDF. So if you remember at the end of the last tutorial, we ended up with a two-piece design that we'd created initially as a single part. So a two-body part, and then at the end of that tutorial we saved those two bodies out as individual parts, and then we arranged them within a true SolidWorks assembly. And then at the end of this session we're hoping to do something similar with this new part, this purple slider part, and then eventually insert that into the existing assembly. So I've got the files from the last tutorial, which comprise of the mouse upper part, the mouse lower part, the mouse assembly, and then the master part, or the multi-body part that we created to control everything. So I have those parts here. So there's the part that's controlling everything, there's the assembly, there's the mouse lower part, and there's the mouse upper. So we're going to be working on this combined part, this part that's controlling all the other assemblies and parts. So mine has been called Mouse Hybrid Model. So I'll load that up. Just a little bit about the terminology there. Hybrid model doesn't refer to the fact that it's controlling the other parts. The term for that is master model. So this technique where a single part leads to the creation of multiple other parts, that's known as master modeling, because this is the master part model and it's controlling the other two parts, and eventually all three parts will be controlled by this master model. The hybrid that I've used in the name there actually refers to the fact that we're using a combination of surfacing tools. So we've been using some tools in the Surfaces tab, and our standard solid modeling tools, which are all in the Features tab here. So that's what the hybrid terminology means. So let's see what we're going to do first. So I'll just have a look at the PDF. So these first two images are just kind of introducing us to what we'll be doing, and then our work begins properly here. So if we just, well, I'm going to take this PDF onto my other screen so I can kind of keep glancing at it and referring to it. So we want to rotate our model over so that we're looking at the underside of the mouse. And then this first step that we're going to do from the PDF, it may not make a whole or a great deal of sense to begin with, but it will make sense later on in the modeling process. So the first thing that we're going to do, we're going to take a copy of that face there. And the way that we're going to achieve this copy, or the way that we're going to create our copy, is we're going to use a tool in the Surfaces tab, and that tool is going to be Offset Surface. So there's the tool, Offset Surface. And this allows you to click on any number of faces on your existing model, and what the tool will try and do is create an offset copy of that face. So you can see the preview here. If I accepted that, we'll create a much larger copy of that face. And the reason it's larger is it's been offset by 10mm in all directions. So as it gets offset, it actually grows in size as well. For these purposes, we want an exact copy of the face. So I'm going to change the offset to 0. So that just creates an exact copy of that existing face. And then I'll accept that. Now that can be a bit tricky to kind of visualize. You can see that the surface in grey and the face are kind of fighting for supremacy there. they want to occupy the same space. So that can cause problems later on. So what I'm going to do temporarily, I'm going to hide that surface that I've just created. So go into Surface Bodies. You can either click on the surface and then click on the hide icon, or you can open up this quite useful set of extra columns that I've got open at the side here. So if you find that little chevron and click on it, you get these extra columns that you can just use to hide and show things as you see fit. So you just click on these icons, and surfaces, or in some cases solids, will appear and disappear. So I'm just illustrating the use of that now. So I like to have those columns switched on. They make the job of hiding and showing things quickly much easier, rather than clicking on something and then having to click on a second icon. Right, so what are we doing next now that we've copied that surface? The next thing that we're going to do is we're going to create a sketch on the lower surface of the mouse that looks just like that. So I'm going to do that now. So sketch on the lower surface, new sketch. I'll probably use the center rectangle for this because I want some alignment with the origin, and the center rectangle will allow me to achieve that a little bit easier. So there's my rectangle sketched out. I'll probably press escape just to get out of the rectangle tool, and I'll try and drag it into an approximate kind of size and shape that matches the image that I was working from. And then I'll start adding relations and dimensions to help lock that in place. The first one that I'm going to put on is a horizontal dimension between those 2 points. And then I'll start adding some other dimensions in. So we'll have a 11 and an 18. And the final one is arguably the trickiest one. I want a dimension between that edge, so I click on the edge, but then I have to hold the Shift key down as I click on this curve. If you don't hold the Shift key there, you'll get a slightly different dimension, which will be between the line and the center point of that curve, which is not what we want for this particular example. So holding Shift down as you click on the curve is the key to getting that dimension that you want, which is the gap between the curve itself, not its center point, so the curve itself and the line that you clicked on. So that's my fully defined sketch. So I want to use that to create an extruded surface. So I was just about to exit the sketch there, but there's little point in doing that. We may as well just go straight to the Surfaces tab, Extruded Surface, and then the system will accept that sketch as input. So the way I'm going to set this up is I'm not going to extrude from the sketch plane. I'm going to put a little offset in here instead, maybe 2 millimeters, so it's just above this surface or below this surface, depending on how you're thinking about it. And then I'm going to flip the direction and just leave it at 10. So hopefully you've noticed by now we're marking out the approximate area that purple slider part will occupy. So that's essentially what we've just done. We've created a cutting tool, or more precisely we've created a splitting tool, because we're going to split this lower body into 2 pieces. Slightly different to the cut operation that we did last time. And similarly to the cut operation, when you create a surface to perform the cut or to perform a split, it's wise to make that surface slightly bigger than the thing that you're hoping to cut. So in our case, we're hoping to cut this lower surface, lower body, sorry. So you can see I've extended my cutting tool beyond the thing that I'm hoping to cut. So the cutting tool's slightly bigger. So the split command is in the direct editing toolbar or tab. There it is. And the first thing that it needs is, what am I going to use as a trim tool? So these always are surfaces, so I'm just going to click on my surface. Surface gets entered in there. Then, because I have multiple bodies in this part, I'm going to specify which body I want to split. So activate this box and then select this lower body. Then I have to click the cut command so the system can calculate how many bodies will result in using that surface to split that body. It's not always 2, that number. It can be multiple bodies that come out of that that combination of the surface that you use and the body that you select. So you have to calculate that, or rather the system has to calculate it. So you click on cut bodies, it does those calculations, and then it offers you the option. It's saying which one of these bodies or which selection of bodies do you want to keep. So I want to keep everything. So I can either click on the bodies here, you can see they're highlighting as I move over them, so I could click and click, or you can go down to this list of bodies and just put a little tick in the ones that you want. And then we just accept the command. And then if we have a quick look in the solid bodies folder, you can see we've got 3 solid bodies now. So we've got the mouse upper, the mouse lower, and what will become our slider part. So there they are, the 3 bodies. At that point, we don't have any further use for this splitting surface, so I'm just going to hide it. As I said last time, my recommendation would be to retain all your surface bodies until you're happy with your design and you're not planning on changing it anymore. And at that point, you could delete them, which is an easy thing to do. You just select the bodies that you want to delete, right click, and there's an option right there to delete them. But it's wise to retain them until that point, because you may find further uses for them, and they're not really damaging anything by being retained. So we've split this slider component from the lower body there. So let's see what we're going to do next in our workflow. So I'm referring back to the PDF. I'm just kind of glancing over. I think in the PDF it recommends, just so that we don't confuse ourselves, that it might be wise to set the colours of our parts to match something like the PDF. That's not just so that we're working on a part that appears the same as the part in the PDF, although that's quite useful. It's also useful if you're working on multi-body parts to designate each body with a slightly different colour. That just makes working on them a little bit easier. So let's do that now. So it's an easy operation to do. If you just click on the body that you want to change the appearance of, and then it's this icon here. And then we can change the appearance of various different things: faces, features, bodies, or the entire part itself. So we just want to change the appearance of this body. And I'm going to give it kind of a pinky, purpley kind of colour, a little bit like the colour that we were seeing in the tutorial document. And then I'm going to do the same operation, but for this mouse lower body as well. And again, it's kind of a bluey, kind of greeny colour, something like that is a good approximation. And then the top of the mouse just retains the overall mouse colour. So my columns that I like to have open at the side of my feature manager here, they actually detail the colours that have been set for various things as well. So you can see this body and this body have had specific colours set. This body hasn't had any specific colour, so it just uses the overall colour of the mouse part itself. So that's how that works. Bodies overrule the part colour, and I believe features overrule bodies as well. So you can play around with those settings and kind of get a feel for them in your own time. So we're going to do some work on the slider part. So I could hide the other parts here manually, but there's a nice little tool that does that no matter how many other parts you have. And the way that you do it is you right click on the thing that you want to isolate and you go down to the word isolate. And the system will hide however many other bodies you have inside that part. And then to get out of isolate mode, there's just a little exit isolate button. So that's quite a nice tool in multi-body parts, but also when you're working on large assemblies and you want to kind of focus on a single part or a few parts and hide all the complexity of the overall assembly. So the first thing I'm going to do in here, my kind of first set of tasks are about creating a hook. So these are kind of hook features that allow you to slide parts together and then have the hook flex slightly and then hook itself onto a groove on the other part. So I'm going to create a hook that kind of runs along the backbone of this part and then sticks out of this end with kind of a little hook surface on it. The first step to doing that is to create a sketch on this face here. And this sketch is just going to be a single point. And I want to put this point exactly midway along that edge. So click. And then I'll press escape to cancel the point tool because I don't want any other points. So that point should have created a relation that fixes it at the exact midpoint of that edge. Now you can put that relation in manually after you place the point if you didn't quite achieve that. But that's what we need. So I'll exit that sketch by clicking on the accept sketch icon. Then the sketch disappears as soon as I deselect it. And that's because I'm hiding everything. All types are hidden up here. So I'll show everything and then I'll kind of selectively hide the planes because I don't need those at this point. And I might hide some of my sketches here as well because they're kind of surplus to requirements at the moment. And then you can see I have my little grey sketch point there. So let's create our fixing hook feature. So this feature isn't available in the features toolbar, although you could customize your toolbar, as I've done a little bit here, and you could add these features in. But if you don't want to do that, they're in the insert menu, in features, they're in fastening feature. And the one that we want is the snap hook. And then after we've created a snap hook on this part, we'll then go and create a snap hook groove for the snap hook to fit in on the lower part of the mouse. So snap hook, and then we just kind of work down these entry boxes from the top to the bottom usually. So the first one is talking about a location for the hook. This is where our sketch comes in. So we want the hook to be exactly central on that edge. So I'm just going to pick that sketch point that I created. I get a preview of what the hook currently looks like with all these settings as they currently are. Then it's talking about define the vertical direction of the hook. What vertical means here is not very clear, but there's an image on the left there to kind of indicate what the system means when it says vertical. So what I'm going to try and do here is I'm going to try and use features that are relatively static in my part rather than things that might change in the future. So as much as possible I'm going to try and use the planes, the primary planes. So in here I want to use the right plane, so I'm going to find the right plane. So let's have a look in here. Here's our part, right plane. So that defines that direction of the hook that arrow is indicating there. Then it's asking me to define this direction of the hook, which it calls, it doesn't even name it, it just calls it the direction. So I'm going to use the top plane for this. That's not bad, but it's pointing in the wrong direction. It's kind of pointing upwards as I'm looking at it. But there's a reverse direction option there. That's looking quite good again. And then the last box is talking about select the face to make the body of the hook. So I'm going to select that top face there. Technically I think that's not really required, but we'll put something in that box and we'll choose that face. And then I'm just going to adjust these settings slightly to the settings that I want, or at the very least I'm going to check them and check that they're agreeing with the PDF. So I suggest you do this and set your sizes for your hook to the sizes that are shown in the PDF. I think because I've done this process once already to write the PDF document, it's retained all my settings. So I suspect your settings may not just be set correctly. So just go through the PDF and just set all these particular dimensions for your hook to what you're seeing here. And then we'll accept that hook feature and it gets added to our part. And there it is in the feature tree. So let's make a related feature on the bottom of the mouse so that this hook has something to locate in, and that will be a snap hook groove. So I need to exit isolate mode, so exit so I can see the whole mouse, and then I'm going to hide the upper body, so I probably use that button there just to do that. And that's okay, I don't mind seeing the hook at the same time as the lower portion of the mouse. And I'm going to go back into the insert menu, fastening feature, snap hook groove. And this is a much more simple feature to set up. So it just really requires 2 bits of input to generate some geometry. So the first piece of input is it's asking for the feature which is the snap hook. So I could try clicking on the model here, but a more reliable way of doing it is to find the feature in the feature tree there and click on it. And then the second thing that it's asking is select a body to put the groove in. So it will be the mouse lower. This will be the body that has the groove in. This is the body that has the hook on it. And the two features fit together when this body is slid into position. So it's this body that I'm selecting. And then it hides the other bodies and it gives me quite a nice preview of what is going to be achieved. So that's okay for our purposes. One thing to note is it's created a groove there, or a indentation, which is exactly the right size for the snap hook. That often isn't 100% appropriate because there may be, or there will always be, manufacturing inaccuracies in some way. So it may be wiser to put some clearance values in. And if you look at the schematic here, there's various clearance values that you can add to this groove. So I would recommend kind of having a play around with some of these values and seeing what effect it has on the groove. But we'll just accept that for the time being. So we've got a snap hook on one part, we've got a snap hook groove that the snap hook locates into. If we want to have a quick look at the 2 items, there's the snap hook groove, there's the snap hook, so everything looks okay so far. And then if I wanted to kind of check a bit further that everything was okay, I might use the section view just to see a cross section of how those 2 features kind of sit with each other. So yeah, I can't really spot anything wrong there. Other things that I could do just to check that there's no problems, I could use the interference detection tool, which you won't have it here on your screen because I've customized my screen slightly, but you can access that tool in the Evaluate tab. There it is. Interference detection. You could do detection on the entire model, but I prefer to target it at the 2 parts that I'm interested in. Calculate, no interferences. So that's a good thing. That means no parts are overlapping with each other. So that's a nice kind of extra check just to do when we're in this sort of situation, or even when you're creating assemblies of parts. It's quite nice. So the next thing that we're going to tackle, we're going to put a pair of runners on that face there, and on that face there, and on the matching faces down the sides of our slider part. So on this face here and on this face here. And the feature type that we're going to use to achieve that is the lip and groove feature. that we used last time. So we used the lip and groove to create these bits of geometry here and the matching bits of geometry on the mouse upper. Well, we're going to use the lip and groove in a slightly different context this time, and we're going to put some lips and grooves down these faces so that this slider part could be slid into position and be guided slightly by those lip and groove features. So the lip and groove feature is in the same menu that we've been using previously. So insert, fastening feature, lip and groove, it's at the bottom of the menu there. And then there's various ways we could set this up. We could designate this body as the body that has the groove on, or this body, and you'll just get a mirror image of the geometry depending on which way around you set this up. But there is no right or wrong. But I'm going to follow what I've done previously, just so that we're all working to kind of these same settings. So that is on this page on the PDF. So I'll guide you through that now. So the body that I decided to put the groove feature on was the bigger of the two bodies, so this piece, and the body that I put the lip on was obviously the smaller of the two bodies, if this had the other half on. And then the system requires a plane or plane of face to define the direction that these grooves and lips will be grown or cut away in. And again, I try to use reference geometry that won't move in the future, that will always stay static where it is currently. So the front plane is a good reference to use for that reason. So then it kind of throws me into this box here, in that it's waiting for some input because the box is coloured in blue. So the groove, and it's hidden the other part, the part that has the lip on, because I'm defining things to do with the groove at the moment. So the faces that I'm going to select are that one there and that one there. Those are the two faces that I want to put the groove features on. And then I have to manually move down to this box, which is selecting edges to define where the groove removes material from. So activate the box. And again, you can play with these settings. I'm going to pick the outer surface of the part. So that edge there will be the edge or the outer surface that you would see if you picked this mouse up and looked at it when it was assembled. You wouldn't be able to see this inner edge. So that's what I mean when I say outer edge. So that edge there, and the corresponding one over there as well. And I get a preview, although it can be somewhat difficult to kind of understand what is being shown in the preview. What is being shown there is the portion of material that will be removed, essentially. So it's showing me a little preview of that. Then I have to manually move on down to select the similar geometry but on the lip body. So I select this box here. So I'm selecting faces again, that's my first job. So it will be this face and this face. And then I have to manually go down to the edge selection box. And I'm going to pick similar edges again. I'm going to pick the edge that's on the outer side of the mouse, and the same around this side. Now, one thing to say at this point, your preview may look slightly different, or you may even get some errors when you try and select these edges. The key thing here is I've just selected two edges. So in order to achieve that, I had to make sure that this setting was off. So this setting should be unticked, this setting should be unticked, this one and this one. So that all the tangent settings should be unticked. Otherwise, what happens is, as you pick one of these edges, the system tries to also pick this edge and this edge and this edge. And that's because they're all tangent to one another. So that's what that achieves. It can be a real time saver. And when we were creating our lip and grooves on the top and bottom of the mouse, it saved having to click on every single curve all the way around the mouse. So it's on by default a lot of the time. So make sure that's switched off in all 4 of those instances. And you should get a preview something like the one that I'm showing there. So the last little bit of setup is just to ensure that our values are correct for our purposes. And again, I would encourage you to kind of play around with these and see the results that you can get out of this feature. But the ones that we're going to stick with, again, my system has retained these values from the last time that I did this tutorial. So you need, working down from the top to the bottom, you need 1, 0, 3 degrees, 0, 1, 1, blank, and 0. So if you want to put those settings in, again, you don't need to kind of do them from the video. You could have the PDF open and they're shown in the PDF. And then we're going to accept that feature. And then we're going to spend a little time just inspecting what we've achieved. So I might use the cross-section tool again just to do this inspection. I don't want a cross-section in that plane, so I'm going to pick a different plane. So I'll pick this one. No, that's no good. I'll try this one. Yeah, that one's better. But I want to drag the plane back to somewhere where the lip and groove are actually kind of interacting with each other. Somewhere there. Yeah, that looks largely okay. I can't spot that there's any kind of overlap between the two bodies. Everything seems fine there. I could delve into that a little bit more and use my interference detection tools again, but I'm not going to do that this time. You may want to do that when you know where the interference detection tool is. So, there's a slight problem with what we've created here, potentially. It depends on our design specification for this product. But I suspect that will be an issue. The fact that the two surfaces there don't quite align with each other at all. There's quite a bad misalignment. This face here should run into this face here nice and smoothly, like these two do. But for whatever reason, the lip and groove wasn't quite able to handle this curved face. So this is where our surface that we grabbed right back at the start of this process comes into play. So hopefully you can kind of imagine what we're about to do. We're about to use the cut with surface option, and we're going to use that surface that we created way back at the start of this tutorial. And we're going to cut away these extra little bits of material here and kind of smooth this portion back so that it matches this face here. Because that's kind of the whole point of using the master model. It's that you can get nice curved surfaces that match on different parts. And you can do that relatively easily because they began life as a single part and then you just separated them at some point. So let's ensure that that's all true. So cut with surface. The surface is hidden, but I know it's in there somewhere, so I go and have a look and kind of try and find it in the surface bodies. So it's clearly number 2. So we click on number 2, and then the only other thing that we have to ensure is we're cutting the right side of the surface, or the correct side of the surface. So at the moment it will cut away my entire part. That's not what I want, so I'm going to flip to the opposite side. And then it's probably wise, again, because we have a multi-body part here, to take control of which body we're going to affect here. So I'm going to unselect auto, and I'm going to specifically tell the system that it's this body that I want to cut. That's by far the safest way of doing it to avoid any problems. And then we'll accept that, and then zoom in. Yep, everything looks good. Those two surfaces run into each other nice and smoothly again. So a little bit of correction work, but we got a bit more practice using kind of surfacing tools for more practical purposes there. Right, let's scroll on down through the PDF. There's a few slides in the PDF, or a few images that are just talking about inspecting the lip and groove a little bit more thoroughly, which you might want to do just to check that there's no problems in there. So the next couple of operations, or couple of features, are going to be relatively simple. We're just going to selectively hide and show our two parts that we're working on, and we're just going to add some fillet features onto the corners of them here. Just so it's for aesthetic purposes, but it's good practice when you're creating injection molded parts, which is the intention here. Try and round as many of the harsh corners as you can, or as is practical. It often creates a kind of more successful molding cycle. So yeah, we're going to put some 2mm fillets on those edges, just 2 edges there. Then we're going to bring the other part back into visibility and just kind of say, uh-oh, we've got a problem there. There's now kind of a little hole. So we can then add a equal size fillet on those edges as well. So we add 2 lots of fillets, just matching each other in terms of their size and curvature. Yeah, that looks a lot nicer. What you could do at that point, you could go in and maybe double click on the second fillet, double click on its size, and then maybe put an equation in here. So we could put an equals and then go and find the first fillet. There it is. Double click on him or her, and then yeah, like that. And that basically grabs whatever the value of the first fillet is and puts a link to it. So you can see the link there. So if I was to change the fillet sizes now, the way that I would go about that would be to change the first fillet size, so this one. So double click on it and then maybe increase it slightly. And then when I do a rebuild, so this is the rebuild button, both sets of fillets match. So that's why you might want to use equations for that purpose, because it minimises the amount of rework that you might have to do if you chose to change those fillet sizes. You only have to edit one value if you put those equations in there. So let's see what we're going to do next. We're going to do a little bit of work on the mouse upper, just to kind of finish things off. So there's some large ribs in here that we created last time. They're doing a good job strengthening up this outer case of the upper. But let's imagine we want to add some electronics or mechanical workings in here. It might be nice to cut back these ribs slightly in certain areas. So that's what we're going to do next. So I'm going to sketch on that surface there. I'm going to just create a simple center rectangle. Kind of something like that will be fine. Just be careful as you're doing that, because it can be easy. So I'll show you one of the things that can be a little bit of a hazard as we're doing that. So I sketch my center rectangle quite innocently, and then inadvertently I attach one of its corners to that piece of the mouse there. So that wasn't my intention, but it's an easy enough thing to do if you're not quite paying attention to how you sketch things. And if I wanted to undo that, it's easy enough just to delete that relation, but it's probably easiest to not do it in the first place. So if you don't intend to put a relation between the corner of your rectangle and one of these lines on the mouse, then ensure that you don't do that. So if I sketch it, say to there, there's nothing to undo. It hasn't attached itself to one of these edges. So just pay some attention as you're sketching things as to what you intend for them. So I'm going to put a horizontal relation between there and there. Horizontal. Then I'm going to put some dimensions on my part, just as the PDF shows. So put a few dimensions on here, and then what is the final one? It's the length of this thing. Yeah, that's what we need. That's fully defined, so I'm going to create an extruded cut using that. I'm going to cut down or up depending on your point of view. So I'm going to cut into the ribs by, let's see how much, 10mm, so that's fine. But I'm always thinking about the fact that this is a moulded part and it has to be relatively easy to remove from the core half of the mould. And if I just create a simple extrude cut here, I'll create some faces that potentially will kind of grip the mould and make it difficult to eject this part from the mould. So because of all that, I'm always considering draft angles where I can. So I'm going to put a 4-degree draft angle on this cut, just to make it slightly easier to remove this half of the design from the mould. And you can see the effect of that, hopefully, relatively easily. These faces are now kind of angled at 4 degrees, so this will be a little bit easier to remove from the mould. So again, staying with the design for injection moulding kind of workflow, I'm also going to put some fillet features on these little edges in here, so all, and these little edges on the outside. There's some icons here that attempt to help me select all the edges that I need, but in this instance I don't think any of these kind of capture what I require, so it's probably easier just to manually go around and select all the edges that I need. And as we've said before, if you happen to select an edge that you didn't mean to select, let me do that, this edge, you just click on the edge again and it deselects. But it can be a little bit time consuming just to go around and grab all the edges that you need. So we're almost there. There. I'll just check the size against the tutorial. 3mm was the intention for these ones, so bump that up to 3mm. Have a quick glance at the preview, check that I've not missed any. Yep, that seems fine. And I think we're almost at the point where we're ready to start saving bodies out. Yes. So I'll show all the bodies again in this mouse. So I'm happy with that. So I'd probably take a save of this part before I begin saving out the slider as a separate individual part. And then what it might be nice to do, well, let's save that slider out first. So we did this in the last tutorial. If you want to save one of these bodies out as an individual part, a real SolidWorks part, you have to right click on the solid bodies folder, save bodies, and then you get some labels attached to the bodies. It can be useful to kind of rotate your view around because it can be misleading. If you're viewing the thing from a certain angle, you may assume that body 2 is this lower and it's not, it's the upper. So just rotate around a bit, get a sense of which body is which. And then the system's just asking me, which body do you want to save? Now I've saved this one and this one last time, so I only want to save this one. So if I click on that one, it knows what I mean. It selects it in the list there. It also names it not very helpful name. So it just takes the name of the last feature that was created on that body. So if I were to change that name, which I do, I simply double click on the fillet 5 solid part. Then I get the chance to decide which folder I want to save this in. So in my case, it's very sensible to use the same folder that has all my existing parts in. So you can see the folder that I've navigated to here. It has the lower, it has the upper, it has the part that I've been working on, the master model part. And it also has the assembly in here as well. So I'm going to name this part mouse slider, just using the naming convention that I've already settled with. Then I'm going to click on save. So at that point, I'm going to click on the tick. Here we go. It is asking me. The template used for making the drive part has different units of measurement to the base part. Do you want to change the unit of measurement of the derived part? It doesn't really matter too much. I think the only difference really is that one uses kilograms and the other uses grams. So yeah, yes or no will not result in a major problem. So I'm going to click on no. And then we're witnessing it just creating the slider part there. And the slider part should now be open within SolidWorks. So I'll go and have a look. Yeah, there it is. So there's our slider part saved out with the name mouse slider. As with the other parts that have been made this way, they don't have any features as such. If I wanted to make a major change to this part, I would go back to the original multi-body part and make the change. And then this part would automatically update, or rather, it would know that the change had been made, and it would say, would you like to update this part? And I could say, yes. I can even say, never ask me this question again, always assume that I do want to update it. So that's how we would make a major change in any of these parts. That's not to say that we can't edit them now. If we wanted to do things to them just in the part environment, we can. So we could add fillets to it. So it's quite a flexible way of working. You can get the majority of the part model created in the multi-body part, and you can manage that geometry from the multi-body part. But then you can do some additional modelling in the actual individual parts themselves. So you can feel free to use a kind of combination of the two. So the last task that we're going to do here, we're going to open up the assembly and we're going to put our new slider part into that assembly. But there's one thing that we have to correct before we do that. So we'll let this open. So there's our overall assembly from last time. It has the mouse upper and the mouse lower. We're just about to bring the mouse slider in, but there's a problem. This model hasn't updated. You can see we're expecting to have a piece of this lower missing there, ready for us to bring our slider part in and put some assembly mates between the two parts. But there's a problem. It hasn't updated. So if we go back to our multi-body part again, this is what we were expecting to see, minus that slider part in the assembly. So why has that not happened? Well, that's got something to do with the fact that we saved these two parts out in the last tutorial, and that save operation is in the list of features here, but it's halfway down or halfway up the list of features. So when those bodies get saved out as individual parts, none of these new features that we've just created in this tutorial have taken effect yet. So in order to correct that, what I'm going to do is I'm going to move these two Save Bodies 1 and Save Bodies 2 features down to the bottom of the list of features here, so that they sit with Save Bodies 3. So Save Bodies 3 was the slider, when we saved the slider out. Save Bodies 2 was either the upper or the lower of the mouse, and Save Bodies 1 was the other one of those, so either the upper or the lower of the mouse. So the mouse at that point looks like that. So that's what is being saved out into the individual parts. We want to save the upper and the lower when the mouse looks like this. Give it a second to update, like that. So we have to move these Save Body commands down below all these features in order for all these features to have taken effect by the time those bodies are saved out. So that's easy enough to do. I just click on one of the Save Bodies features to select it, and then click and hold, and just drag it down the list to where I require it. The system will reorder things. It'll take it a second or two. You saw it there. And there's Save Bodies 2. So I'll do the same thing again. Click on Save Bodies 1 to select it, try that again. Click off it. Click on Save Bodies 1. Yeah, there we go, selected. Click and hold and drag. Give it a second to reorder everything. Yeah, and then I'll maybe take a save at that point just to ensure that if everything crashes, I don't lose that. And then if I go back into the assembly, so there's the mouse assembly, it quite rightly says models contained within the assembly have changed. Would you like to rebuild the assembly? Yes, I would. And as I said, there's a tick box in there where you can say, don't ask me this again, just assume yes. So if that is becoming annoying and you always want the assemblies rebuilding, then just select that option. So now the upper and lower are in their state from the end of this tutorial rather than the end of the previous one. So now I can insert my slider component. The slider is already open in SolidWorks, so I can just select it from that list, click and drop it in the assembly, and then begin the job of mating it into an appropriate position. So that plane and that plane, I'm going to make them coincident, and then that surface there, that surface there, I'm going to make those two coincident, and then that surface there, and that surface there. Make those two coincident. That looks good. So that's pretty much it for this tutorial. We may return to the mouse design in the future. Obviously, in order to function as a mouse, we could do with some sort of button or buttons kind of integrating into the design. There's other things to think about. How are the two halves going to be fixed to each other? So we could maybe look at some options for fixing them together. But in terms of this tutorial, that concludes everything. One thing that you would do at this point is you would then take a save of the overall assembly. And SolidWorks says, do you want to save all the parts as well? Yeah, that's not a problem. Do you want to rebuild them before you save them? Yeah, I can't see a good reason not to. And then we should have a save of everything, and then we can close SolidWorks down knowing that we've saved everything into our folder. So let's just have a quick look at our folder. Yeah, so we have the model that's controlling everything, we have the overall assembly, and we now have 3 rather than 2 real SolidWorks parts that are called upon by that assembly. And as long as we remember, it's wise to keep all of these parts and assemblies all together in a single folder. So that would be my last kind of a piece of advice is don't start moving these files into other folders thinking you're being tidy with your organization within your foldering system. It will only cause things to not work. SolidWorks expects all of these files to exist with their current names in one location, so in a single folder. And if you start changing that, things won't talk to each other anymore. So the master model may not be able to find the files. The assembly may not be able to find the individual part files. So when you've decided on the names that you're going to give them, try not to change them or do not change them. And when you create them and put them all in a single folder, don't then start separating them into individual folders, because things will stop working and you'll get errors. And it will take quite a reasonable level of SolidWorks knowledge to solve those errors then. So keep it nice and simple, keep them all in a single folder. When you've decided what their names are, the first time that you save things, don't change the names, and you should be fine.